Okay, in this workshop, I will cover two topics. This is one of the topics here, solving logarithmic and exponential equations. Another one will be trigonometric equation. Okay, this is a guideline of solving the logarithmic equations without substitution. Okay, you know, sometimes the equation can be transformed into quadratic equation if there's a square, right? And that's the time you need to do the substitution. But this case is without substitution. That means you won't see any square. Okay. So first of all, you have to make sure that the equation is logarithmic. Okay, that means the equation has the word log first, because we have different methods to solve for exponential equations or logarithmic equations. Two different methods to solve for two different equations. So now you have to check whether all the logs have the same base or not. This is very important. Without the same base, you cannot apply the law of logarithms. So you need to check whether they have the same base. Next, okay, so what? If no, let's say it's no, then what you need to do? If they don't have the same base, you have to change to the same base. Okay, change to the same base. So how do you do that? Okay, you should know already the formula of changing the base. You should know already. And by changing the base, you will have a denominator, right? You have a fraction there. And in this case, the fraction, I assume that there's no variable. Sometimes it could be variable. This case is no variable. We will see the next topic is with variables, and we will see how to solve it. Now we only focus on no variable. And you want to remove the denominators. We always don't like the fractions. So we remove the denominators by multiplying the Lcm of denominators to the equations. You know this one already. This is how we simplify the fractional equation to without fraction equation. Now, this one, if they have the same base, what to do? Right? If the equations, they don't have the same base, you change to the same base and then simplify the equation, right? And this one, if they have the same base, you have to check whether the number in front of log is 1 or not. Okay? So after you simplify this equation here, also go back to check this one. Okay, whether the number in front of log is 1 or not. Because if the number in front of log is not 1, you cannot apply the law of logarithms, right? So remember, if no, then how? If yes, then what should we do next? Okay, so let's check this one. If the number in front of log is 1, okay, check whether it's 1. No, if no, you have to move the number to the back and make it becomes power. Okay, move the number in front of the log to the back to make it become power. Okay, if the number in front of log is 1, then you can proceed. You can proceed to what? Proceed to put all the log terms together at one side. Okay, you put all the log terms at one side, and then you put the other terms to the other side. Okay, and then apply the law of logarithms. Now only you apply the law of logarithms. Make sure the equation now is in the log form. Okay, after you have done all the steps, the previous steps, you should reach to this log form already. The log form, it means single log at one side. There's only one log at one side. Then we have a number at the other side. Okay, this is what we call log form. And then change the log form to index form. So all of you should know already how to change from log form to index form. Then solve for the equation. The last one, verify the solutions. You always have to verify the solutions. Because sometimes the solutions, if the x is inside the log, the x cannot be negative or 0, right? So you have to verify it. Sometimes the solution that we get from here is negative or 0. Okay, now let's look at this first example. Do we have the answer? Okay, never mind. This one. So we solve this one. Okay, let's look at a guideline or flow chart. Okay, first thing first, you have to make sure that this equation is logarithmic. That means you see the word log. Then only proceed. If you don't see the word log, then we use another method. Okay, check whether all the logs have the same base or not. Is it they have the same base? There are two log terms here. The base here is 4. This one is base 2. So they don't have the same base. So it's no, right? No, you should do what? Change to the same base. All right, how do we change? You should know. So when we change the base, we normally change from the bigger base to the smaller one. Okay, so we keep the 2, we don't want the 4. We want to change the 4 to 2. here we start to change. Right, you know that when you change this, you always have a fraction. And these two fractions involve log. And the base for this top log here is the base that we want. Okay, always the base that we want. Here is 2, this one also 2. Okay, how about the number inside the log here? This number here is actually the 3x. And this number here is actually the base of this 4. Okay. So this is how we change. All right, after you change, what should you do next? Simplify the denominators, okay? As you can see, we have the denominators here, right? This is not a variable, it's a constant. So you can simplify this. You can use calculator, or you can make it to 2 square, bring the power 2 to the front of the log, and you know that log base 2 of 2 is 1. So this one is actually 2. Okay, if you don't know to simplify it, just use calculator to help you. So this will be log 2 log base 2 3x over 2. And what you see here, 2 cancel out. All right, what should we do next after you simplify the denominators? Okay, here you can remove the denominators, but in this case, because the denominators cancel out, so you don't need to carry out this step. So what we do next is check whether the number in front of log is 1. Now you should start to check whether the number in front of log is 1 or not. Yes, right? You see, the number in front of log is 1. This one also 1, right? No problem. So you don't need to do anything. So let's proceed. All right, let's go to put all the log terms together. All right, so we know now the number in front of log is 1. Yes, proceed to put all the log terms together at one side. So we have log terms here, we have log term here. So put them at one side, okay? So I move this one to here, the left-hand side. And I move the -2 to the right-hand side. Okay. Next, put the other terms to the other side. Yes, that's what I did just now. Okay, apply the laws of logarithm. Now you apply the laws of logarithm. Okay, you know. So this is a difference of 2 logs. You want to make it to a single log, you should use what? You know it is division, right? Division. 3x plus 10 over 3x. And then equals to 2. Then from here, what should we do next? Okay, at this step, you should reach what? You should reach at this one, form, log form. You should get this one already, log form. Log form means you have a single log. Here is only one log at one side. Then the other side, it has a constant or number at one side. So you want to convert this. Let's see, the next step here is what? Change the log form to index form. Right, change the log form to index form. Okay, how do we change? Okay, you have to identify which one is the base here. Here, this small number here is a base, right? So 2 to the power of something, right? So you always know that the result of this log is always the power. Always remember the purpose of using the log is to find the power. So the result of the power is always, the result of the log is always the power. So 2 here means the power. It means 2 to the power of 2 will be equal to the number inside the log. All right, so this is how you change from the log form to an index form. Now, what should we do next? Solve for the equation. All right, solve for the equation. So now you know how to solve this. Okay, I will move to, okay, let's say here it become 12x equals to 3x plus 10. 9x to 10. Okay. So x equals to 10 over 9. Okay. So after you solve the equation, you have to do what? Verify the solutions. Okay. You try to put this 10 over 9 into this equation, whether you can, whether the equation valid or not. Okay, we try to do that. Okay, here is my calculator. Okay, I will have a log here, base 2, and then the 3 times 10 over 9 plus 10. All right, and then minus 2. Okay, you will have what? 1.737. Okay, 1.737. This is for the left-hand side. Then right-hand side. If left-hand side and right-hand side are the same, then that means this answer is correct. Three times 10 over 9. All right, it's correct, right? Same, both sides are the same. So now you confirm that the solution is 10 over 9. Okay, next one. We have log base 9 of x plus log base 3 of x squared equals to 5. So do you remember our first step? Our first step. Always check what? Whether they have the same log or not. Same base or not, right? Here again, they don't have the same base. You should change the base to base 3. Oh, sorry, this one should be converted to base 3. We do want the 9. X here, 9 here. All right, plus the log base 3 of x squared equals to 5. Okay, so your next step is what? Simplify the denominator. Still no variable here. Still no variable here. So you know that this is also 2, right? All right, in case you don't know how to simplify this, just use your calculator. Okay, key in this one, you will get 2. All right, then we have a denominator here, right? So what should we do? Remove the denominators by multiplying the LCM of denominators to the equation, right? So here we only have one denominator, just multiply this equation by 2. So each terms you need to times 2. So you have log base 3 of x, right? Now no more denominator. And this one, you have 2. And this one is 10. Okay, now let's go to the next step. Next step is you want to check whether the number in front of log is 1 or not. So you're going to see we have 2 log terms here. We have 2 log terms here. This one, the number in front of log is 1. Okay, no problem. But this one is 2. So what should we do with these 2? You should move the number to the back and make it become powers. Okay, so move the 2 to the back to make it become power. Okay, move to the back, become a power, but here originally it has the power 2. So 2 times 2, you get 4. Move it 2 to the back, become the power. So 2 times 2 is 4. And now, put all the log terms together at one side. So as you can see, we only have log terms at one side. You don't need to move. And then put the other terms to the other side. Yes, we have the other term at the other side. You don't need to do anything. Then apply the laws of logarithm. So this is plus. You know that we can change it to a single log using the multiplication, right? So this straight away becomes x to the power 5, right? X times x to the power 4 is x to the power 5. Okay, equals to 10. So now at here, you should have the log form ready, yeah? All right, log form. You should have the log form, that means log term at one side and a number at the other side. And then change log form to index form. Okay, you should know it is 3 to the power of 10 equals to x to the power of 5. And try to solve for this equation. Okay, solve. How do we solve for this kind of equation? You want to look for the base. But normally we look for the power, right? But this question, we want to find out the base. So one way to do it is try to make sure they have the same power. Okay, you want to compare the base. You have to make sure that their powers are the same. So here you can have what? 2 times 5, right, equal to 10. Okay, and then this one, you can make it as 3 squared, and then we have the power of 5 outside this bracket. And then equals to x to the power of 5. Right, so from here, you see that both sides have the same powers. Now you can compare the base. So x equal to what? X equal to the number inside the bracket here. 3 squared, that means 9. Okay, so after you solve for the x, you have to verify the solutions. Verify the solutions. So, okay, is it correct now? If 9, this is 1, 9 squared, 81. Let me check for it. Okay, so let's check for this one. Nine plus log base 3. 9 squared, right? And try to check whether this equals to 5 or not. Yes, it's 5. Then confirm this is correct, and you get full marks for this question. Okay, question number 3. For this question number 3, after you change the base, you don't actually need to put the log terms together. This one you don't need. If you have only log terms, you don't need to actually move all the log terms together, put it together. You just need to compare both sides. All right, for this one, you need to change the base from 25 to 5. Okay. Then from here, you have these two. Okay. And then you move the 2 to here. Becomes 2 log base 5 of x minus 2 equals to log base 5 of 2x minus 1. Again, you see the number in front of log, you should move the 2 to the back. All right. So from here, you actually don't need to put the logs term together at one side. Now you can actually do what? Compare both sides. Compare both sides. Okay, because both sides having the single log with the same base, that means the number inside the log must be the same. Right? This one must be the same as this one. So now you can have this equation. X minus 2 squared equals to 2x minus 1. Then you expand this, you have x squared minus 4x plus 4 equals to 2x minus 1. X squared minus 6x plus 5 equal to 0, right? From here, in the math class, you already know how to solve for this quadratic equation. Again, you have learned. So I use the ordinary method. Okay, I will start with the factorization first, then I get the answer. Why I can use this one? Because this is actually simple quadratic equation. I can actually guess for the factor. Okay, so this one I know here is 5, 1, negative, negative. So now you can get it x equal to 1 or x equal to 5. But don't just stop here. And to verify it, whether it's possible or not, is it x equal to 1 possible or x equal to 5 possible? You put a 1 into this equation, what happened here? 1 minus 2 is what? Negative. So you see that the number inside the log is negative, which is not a log. So this is rejected. How about 5? 5, no problem, right? 5 minus 2 is 3 is positive. 5 times 2 is 10, 10 minus 1 is 9. It's still positive. So we allow for the x equal to 5. So the only answer is only x equal to 5. Huh? So always check for the answer. All right, next. Okay, this is another case with substitution. That means the denominator is not a variable. I mean, it's not a constant, it's a variable. Okay, it's a variable. So how do we solve this kind of logarithmic equation? Do the substitution for the log term and transform to the quadratic equation. And then remove the denominators by multiplying the equation by the denominators. Okay, this one you know. Okay, this is how we simplify the fraction. And then remove the denominators by multiplying the equation. Okay, this is the same thing. And then solve for the quadratic equation. Go back to the substitution. And then solve for the exponent. Okay, again, you have to verify the solutions. So let's see this question. So what happens if the denominator is variable? All right, you know the first step. Always make sure this equation have the same base. So now the base here is 5, this one is x. You should change to base x or base 5. You should always change to the base that has a value, the fixed value, not the variable. So you should change x to 5. Here we have 5, here we have x. With 5, all right, you can simplify this. Log 5 of 5, log base 5 of 5 is 1, so 1 times 6, 6 over log base 5 of x equals to 5. Okay? So what you see here is that this denominator is a variable, right, in terms of x. So what should you do? You should do the substitution now. Okay, you know that you can transform this to quadratic equations. So here's the key part. When you see the denominator is a variable, you need to convert this to quadratic equation. So you can let u equals to log base 5 of x. Okay, let the denominator becomes u. Now you transform this to u minus 6 over u equals to 5. And then how should we remove the denominators? Just time this equation with the denominator, right? So we u squared minus 6 equals to 5u. And then you move the 5u to the left-hand side. Okay, this is still minus 6. Equal to, start to do the factorization. Plus, minus. So u equals to -1 or u equal to 6. But don't just stop here. We are not looking for the u. We are looking for the x, right? X. So you can make the log base 5 of x equals to -1 or log base 5 of x equals to 6. So now you can find out the x. Right? Change this one to index form. 5 divided by 1. This one, 5 about 6. This gives you 1 over 5. This is 5 about 6 is a very big number. Okay? So this one, try to verify the solution. Is that possible? 105, 105. Yeah, it's possible. Okay, let's check using the calculator. Is 5. You check for 105 first. Minus log base 105. And then 5. You see we get 5? Yes, it's 5. So it's correct. Same to the 5 about 6. So you can do it on your own. All right, this is question 2. Okay, question 2. So what's so special about this one? I think it's about the same. Log base 2 of x equals to log base x of 4 plus 1. All right, so this one, again, make sure they have the same base. Now they don't have the same base, just change to base 2. Here is 4. Bottom here is x plus 1. And now you see the denominator here is, all right, you should do the substitution. Transform this to quadratic equation. This one you can make it to 2. So just let u equals to log base 2 of x. And now you transform these to u equals to 2 over u plus 1. So you have u squared equals to 2 plus u. So you have u squared minus u minus 2 equal to 0. Now, can you solve this? it can be factorized. U 2 1 plus minus, yes, can be factorized. So now u equals to -1 or u2. Go back to our substitution. Log base 2 of x equals to -1 or log base 2 of x equals to 2. Now you know that x is 2 to the power of -1. And this one, x equal to 2 to the power of 2. So this is 4. And this is 1 over 2. Is that possible? Yeah, still possible, right? And then just verify the solution with your with this original equation. Make sure it's correct. All right, let's go to this example. Okay, these are other types of the, okay, just show you the steps. So in this case, as you can see, we'll make sure that they have the same base. Yes, that they do have the same base. And then here, the number in front of log is not 1. That's why I moved to the back. And then now from here, you can actually compare the log number inside, the number inside the log for both sides. Okay, then you have this one, then so for this, you have, okay, these two answers. This one, again, this one, be careful. X equals to -3 is undefined, right? Because the number inside the log cannot be negative. That's why you have to verify the solutions here. So this is rejected. Actually, okay, this is 4. The only answer is actually 4. So now we go to B. This one, again, the number in front of log is not 1, but before that, you have to make sure they have the same base. They don't have the same base, all right? Change the base. Then you have this one, all right? And then you can let y equal to this one. You have this equation transform to the quadratic equation. Again, when you solve, you have plus minus 5. So is that possible? You have these two answers. Yeah, it's possible. Okay. But this one you can do it on your own. Okay, this one just skip. All right, now we go to this one, exponential equations. So we are done for the logarithmic equation. Now we come to exponential. I know a lot of people, okay, like to use the laws of logarithm apply to this exponential equation. They always like to take log for both sides, right? I think you learn this from many teachers, but I don't recommend that because it takes time and the working is quite tedious. You just can straight away apply the laws of indices. No need to apply the law of logarithm. You only apply the law of logarithm when you find that the power is not rational. Then you just apply the log. Okay, let's see how. Make sure the equation is exponential. That means what? The power is a variable, no logs. If you found the equation has no logs, then you apply this method. Check whether the indices have the same base or not. Very important things. Just like the log, we always want to make sure they have the same base. So in this exponential equation, you also have to make sure they have the same base. If they don't have the same base, then how? Then you have to check whether the indices are possible to have the same base. Sometimes they are not possible to have the same base. Okay, it's not possible to have the same base. So if they do have the same, if they are possible to have the same base, then you can proceed to change to the same base. We will see how if they are not possible to have the same base. We will see this one in another case. Okay. So, and then after you change to the same base, you simplify the power. With this one, if they have the same base, then you have to check. The next one, you have to check whether the operation of the indices is multiplication or division. This is very important. Okay, because this will decide whether you should apply the law of indices or not. Okay, so if yes, if the operation of indices is multiplication or division, then you can apply the laws of the indices. If cannot, okay, let's continue to this one first. After you apply the laws of indices, you can equate the exponents, okay? And then solve for the exponent. and then verify the solutions. Okay, these are standard steps, okay, to get the answer. What if the operation is not multiplication or division? You cannot apply the laws of indices anymore. This one, you use substitution method. Okay, then transform to quadratic equation. Again, solve the quadratic equation, go back to the substitution, and then, and then after you go back to substitution, go back to solve the exponent, again, verify the solutions. Okay, you go another way here. If there's no multiplication or division, you go to here, then come back to this one. Okay, let's see. This is for the case if they are not possible to have the same base. Sometimes it's not possible to have the same base, okay? Then what should you do? Break the indices that have the variables power expressed in one term. What does it mean? I think I will show you. Okay, break the indices. Okay, the keyword here, break the indices. And then move the indices that have the variables power at one side, and then move the constant to the other side. And then make sure the equation now is in index form. Then only apply the log. Here, I always only apply the log at the last step to find out the power. I wouldn't take the log both sides at the beginning. It makes the words tedious. And then solve for the exponent. Verify the solutions. Okay, let's see this one. All right, let's go back to see our flow chart. What should we do for the first step? Let's go back. All right, here is the flow chart. Check whether the indices have the same base. No, right? They don't have the same base. So you should check again whether indices are possible to have the same base or not. Is that possible to have the same base? Yes, they do. I mean, that can be converted to the base 2, right? For all these index forms. You can change them to the index form with base 2. So it just change to base 2. So 8 is 2 to the power of 3. And then times with this power, you have 3m plus 3 equals to 16 is 2 to the power of 4. So it's minus 4m here. All right. And then what should we do next? So change to the same base. After that, simplify the power. I have simplified the power. And then check whether the operation of indices is multiplication or division. You look at the indices here. All this index form, is it involved in multiplication or division? Yes, here you see we have multiplication. So that means you can apply the law of indices. Okay? Apply the law of indices. So now you apply the law of indices. So what should we do? If multiplication, you know that you just add the powers. Equals to 2 to the power of -4m. So this one, 3m minus m is 2m. 3 plus 3 is 6. So 6 plus 2m equals to 2 to the power of -4m. All right. And then equate the exponents, right? Equate the exponents. So now, as you can see, both sides have the index form with the same base. Of course, their powers must be the same, right? Because here is the equation. Left-hand side must be equal to right-hand side. So power from the left-hand side must be equals to the power from the right-hand side. And now you solve for this equation. And now in the end, you have this m equals to -1. Okay, so this is the typical questions of indices. It's not that hard. Okay, let's check for the another one. Okay. We go to question 2. 3 to the power of 2x plus 9 equals to 3 to the power of x plus 3 to the power of x plus 2. All right, now you know already. Our first step is want to make sure this equation, I mean, all the index form can have the, they need to be, have the same base. But the thing is, t is plus, it's addition, it's no longer the multiplication. All right. Okay, for this kind of question, then how? You see, right, in the flow chart, I say you have to make sure that the operation between the indices is either multiplication or division. Then only you can apply the log indices. But now this is not multiplication or division. So we should do what? Substitution. Okay, we need to transform this to quadratic equation already. You can let u equals to 3 to the power of x. And now see this one is what? If you take the square for both sides, you have u squared equal to 3 to the power of 2x. And now you know that this 3 to the power of 2x is actually u squared. And then this is 9. All right, 9. 3 to the power of x, u. This one. So how do we replace this one? Okay, 3 to the power of x plus 2 is actually what? You can break the indices, right? Into 3 to the power of x times 3 to the power of 2. Okay, this one you can make it to 3 to the power of x times 3 to the power of 2. Now you have this is what? U. 3 to the power of x is u, and then times 9. So now you know this is actually 9u. So here, plus 9u. So now you can simplify this, right? U squared and then 10 minus 10u plus 9 equals to 0. Now you can start to solve with this quadratic equation. U, 9, 1, negative, negative. So u equals to 1. Or u equals to 9. Now don't just stop here because we are looking for the x, not the u. So well, x equals to 1 or 3 to the power of x equals to 9. So x equals to what? So this one, we do have the same base. You cannot just equate the exponents, okay? You need to apply the log, the log, okay? Use the log to get the, the exponent. Change to the log form, log base 3 of 1. All right, this one. This one you still can, oh, this is not that hard actually. Because 1 is what we call zero exponent rule. Zero exponent rule. You know that to get 1, the power must be what? 0. You know already. 3 to the power of 0 is 1. So this one you don't need to apply log also can. So it's 0. This one is 3 squared. 9 is 3 squared. So x equals to 2. So x is 2. All right. So this is not the, I mean, still okay, this one, this question. Now we go to question 3. So question 3 is the things that I mentioned just now. A lot of people will go to take log for both sides and then move the power to the front. I will show you the first method and compare with my method. You see the difference, huh? All right, this is most of the teacher will teach you. Take a log for both sides. Okay, they will ask you to take the log for both sides. It's okay to take LG or LN, up to you. Okay, and then they will ask you to move power to the front of the log. And then, okay, and here we have different approach. You can either use your calculate LG2 is what? Get the decimal number. LG5 is what? Get the decimal number. You can do that, or you just want to keep with the log. From here, you're going to expand it. Getting complicated now. So x log of 2 plus 3 log of 2 equals to 2x log of 5. All right. Then not yet finished. You still have to put the log terms and the like terms together, x and x. Simplify it. You can. Okay, I will bring this one to the right hand side. And now you have the common factor x. So now you can factorize the common factor x. At last, you can find the x using a law of LG here. So x equals to 3LG2 over 2LG5 minus LG2. For me, it's quite tedious and too long already. A lot of logs need to write. So I will go to, okay, another method. Okay, let's see the difference between these. Okay, when you see this exponential equation, you should always apply the log indices, not the log. Okay, this one, what should we do? You see, they don't have the same base, right? You check, okay, they don't have the same base. And it's possible for these two index ones have the same base also. You can't change 2 to 5, like it's not possible here. Okay, so what you're going to do is just break the indices. Break the indices. How you break? This means what? Right. And this one you can keep with, you don't need to break, right? You just keep with power 2x. So from here, you just rearrange the index form. Okay, you want to, let's say you want to move this to the power of x to the right hand side. What should you do? Divide, right? Okay. And then what if find x? In this fraction, we have x on the top and at the bottom. So you should take out the common power x. They have both common power x. So take out the common power x. And now you have this one. Okay, this is actually 8. So 2 power 3 is 8. Now you can start to find x already. Okay, you can start to find x how? Using what? The log, change to log form. So log, what's the base here? A bit complicated. This is the base. So basically it's 75 over 2. This is the base. And then this is the number inside the log. I just use one time log. I can get the x. You see the difference between these two. And I don't know why a lot of teachers will teach you this one. If you go to tuition, they will teach you this one. Okay, so what do you get? Let me check. Okay, so it's 0.8233. How about the other one? Is it correct or not, this one? I'm going to make sure both also correct. LG 2 and then 2 LG 5. minus log2 is the same answer. Yeah, same answer. Okay.